Hello everyone, welcome to Engineered. In this video, we'll be doing this particular problem. A village in Mid-Western Development Region of Nepal has a design year population of 500. In per capita demand recommended for that particular village is 65 liters per day. The demand is to be met by a continuous system of supply from a spring source with safe yield 0.4 LPS. The consumption pattern is given as below, and is balancing storage tank necessary and calculate its capacity if necessary, right? So if I say here it is the reservoir and this is the demand side, right? And here is the supply side to the reservoir. This is the spring source. So here is the supply side and here is the demand side, right? Now for the demand side, this table gives us the value, right? Because water consumption is given in the table. Now for this particular thing, we need to first find the demand side, right? So total demand is, so for one person it is 65 liter per day, and we need to calculate for 500% people, right? So it will be 65 into 500 liter per day, right? So it will be 65 into 500. It will be 32500 liter per day. Now this demand is in 1 day, right? 32500 liter is in 1 day. Now in 5 to 7 hours it will be 25%, right? 25% of what? 32500. Let's calculate here the demand, actual demand in a particular time frame. 0.25 into 32500, right? 25% of 32500 is 8125. 35% of 32500 is 11,375, and 15% of 32500 is 4875, and 20% of 32500 is 6500, and 5% is 1625. Now this is the demand, right? Now for the supply part, it is said that the demand is to be met by a continuous system of supply from a spring source with safe yield of 0.4 LPS. So safe yield is given. Safe yield is the minimum value that can be supplied by the minimum yield that can be provided by the particular spring source, right? So it will be 0.4 LPS, right? So now we turn the value in liter per hour, right? Because we have divided the table into different hours, right? So it will be 0.4 into 60 liter per hour, right? So it will be 0.4 into 60 into 60. It will be 1440 liter per hour. So here is for the supply side, and this is for the demand. So let's go to the table. So here is the table, and this is according to this consumption pattern. Now for the demand part, let's copy these values: 8125, and then 11375, and then 4875, and then 6500, and 1625. Now for the supply part, it will be 1440 into time, right? The time is given here. So the first 1440 into 2, right? It will be 2880, and into 5 in the next, it will be 7200, and again 7200 because time is same, and for the 2 it will be 2880, and for the 10 it will be 14400. Now for the surplus, if supply is greater than demand, and for the deficit, if demand is greater than supply, right? Now let's calculate the first one. Supply is lesser in the first row, demand is greater in the first row. So 8125 minus 2880, right? So it will be 5245 in the deficit part, 5245, right? And in the supply part, it will be in the next row it will be 11375, minus 7200, right? It will be 4175 in the deficit part because demand is greater. Now supply is greater in this third case, right? So 7200 minus 4875, it will be 2325 in the surplus part, 2325, right? And in the second last part, 6500 minus 2880, it will be in the deficit side because demand is greater, 3620. And for the last one, it will be in the supply side, surplus side, because supply is greater, 14400 minus 1625. So 1, 7, and 5. Now for the capacity to be calculated. Now let's see. Capacity equals to, if you see here, so for the capacity we need a maximum deficit value, right? So how can we get the maximum deficit? If I add this and this, it will be maximum, right? But let's see, this is negative 2325, right? And this is positive 3625. Negative is less than positive, right? So if I take this and this, it will be greater than the sum of these two, right? So let's verify this. So if I add 5245 plus 4175, it will be 9420, right? 9420. Now, is this the maximum deficit value? Let's check. If I go here 2325, it will be minus 2325, right? And it will be 7095. It is lesser than 9425, right? So I can go here only. Let's take this 3620 now plus 3620, right? It will be 10715. So this value is greater than this, right? So this is the maximum deficit value. So our answer will be 5245 plus 4175 minus 2325 and plus 3620, right? Now let's do 5245 plus 4175 minus 2325 plus 3620. It will be 10715 liter, right? So let's do this in a different method. So demand, let's copy demand. Demand is 8125. Now let's find the cumulative demand. The first one is 8125 itself. The second one is 8125 plus 11375, right? So it will be 19500, and again adding 4875, it will be 2424375, and again adding 6500, it will be 3030875, and again adding 1625, it will be 32500. Now for the supply part, it will be 2880 in the first part, right? 2880, and the second is adding 7200 in that, right? So 10080, and again adding 7200, it will be 17280, and again adding 2880, it will be 20160, and again adding 14400, it will be 3456 and 0. Now for the cumulative surplus, it will we write in this column if cumulative supply is greater, right? And in this table if cumulative demand is greater. Let's see in the first row, it will be 8125 minus 2880, right? So it will be 5245 in the deficit part, 5245. And again 19500 minus 10080, and it will be 9420 in the deficit part, 9420 in the deficit part, and again 24375 minus 17280 in the deficit side as well, right? 7095, and another 30875 minus 20160, it will be 10715 in the deficit part. The last one also, in the last one, cumulative supply is greater, right? So it will be in the surplus part, 34560 minus 32500. So it will be 2060, right? Now capacity is given by max cumulative surplus plus max cumulative deficit minus total supply plus total demand equals to maximum cumulative supply surplus is 2060 and maximum cumulative deficit is 10715 and minus total supply is here and total demand is here and total supply is here 34560 plus 32500. If I calculate this, 2060 plus 10715 minus 34560 plus 32500, it will be 10715 liter, right? So in the previous method it was 10715 and here also 10715. So that's the answer. Thank you for watching.